This video is on the sum and difference of cubes. A sum or difference of cubes is a polynomial in the form a cubed plus b cubed or a cubed minus b cubed. These expressions can be factored as followed. A cubed plus b cubed is equal to the quantity a plus b times the trinomial a squared minus ab plus b squared. And the difference of cubes, a cubed minus b cubed, can be factored into the quantity a minus b times the trinomial a squared plus ab plus b squared. Here's how I remember these formulas. Notice that if it's a sum, then your first factor also has addition there. If it's a difference, then we also have first factor also has subtraction. They both start with an a squared, they end with a b squared, and there's just an ab in the middle. Notice this is different from a perfect square trinomial. Remember, it kind of looks like a perfect square trinomial, but we had like a 2ab in the middle. This has just an ab in the middle. But then the sign of that term in the middle of the trinomial is going to be opposite of what you started with. So for a sum of cubes, we're going to have a minus ab. For a difference of cubes, we're going to have a plus ab. To use these formulas, it's easiest to identify the values of a and b and then just substitute them. So let's take a look at a couple examples here. We need to find each sum or difference of cubes, and my first one is x cubed plus 8. I'm going to start by rewriting that as x cubed plus, and 8 is actually 2 cubed. So that shows me right away that my value for a is going to be x, and my value for b is going to be 2. So this is a sum, so I'm going to use this formula here, a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. And now I just substitute in those values. So a plus b is going to be x plus 2, and then a squared is x squared minus a times b is 2x plus b squared is 4. And that's factored. And this trinomial, even though it looks like you might be able to factor it, you can't. That's prime. So this is your solution here. So x cubed plus 8 factors into the quantity x plus 2 times the quantity x squared minus 2x plus 4. Number 2 here says 64x cubed minus 125y cubed. So this one's a little more complicated. So the cube root of 64 is actually 4. So 64x cubed is going to be the quantity 4x to the third power. So 4x times 4x times 4x is 64x cubed. Cube root of 125 is 5. So this is going to be 5y, that quantity to the third power, because 5 cubed is 125, y cubed is y cubed. So this shows me that a is equal to 4x. A is whatever is being cubed to get this first term, and b is equal to 5y. b is whatever is being cubed to get my second term here. And then for this, I'm going to be using the formula a minus b times a squared plus ab plus b squared. Notice that in both of these, it's always a positive b squared plus b squared in the end. So that's going to give me 4x minus 5y. And then here's where it gets a little complicated. So I need a squared, and a is 4x, so I really need 4x squared plus a times b plus b squared, or 5y squared. I'll tell you the mistake I see most people make is they don't think of the quantity 4x being squared. They just write 4x squared, which is really only squaring the x, not the 4. So my final answer is going to be 4x minus 5y. And then let's clean up in here. So the quantity 4x squared is 16x squared plus 20xy plus 25y squared. And even though that might look like it could be a perfect square trinomial, it's not. That's prime and cannot be factored. And let's take this one step further and use, in this case, a difference of cubes to solve the equation 8x cubed minus 27 equals 0. So that's the same as saying 2x, the quantity 2x to the third power, minus 3 to the third power equals 0. So a is equal to 2x, and b is equal to 3. Notice b is not negative 3. b is just going to be whatever is being cubed and then subtracted from your first term. So this is going to give me a minus b times a squared, which is 4x squared, plus a times b, 6x, plus b squared, which is 9, and that equals 0. So I have two factors. 2x minus 3 equals 0, and 4x squared plus 6x plus 9 equals 0. So solving this one, x is equal to 3 halves. There's one of my solutions. And remember that I said even though this might look like a perfect square trinomial, it is not factorable. So the only way to solve this equation is to use the quadratic formula. So x is equal to opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. So that's going to give me negative 6 plus or minus the square root of 36 minus 144, I believe, over 8. Whoops, it's not a very good 8. Which gives me negative 6 plus or minus the square root of negative 108 over 8. So I've gone into imaginary number land. So simplifying that, the square root of negative 108 is going to have an I, and then the square root of 108 is 6 times the square root of 3. So x is equal to negative 6 plus or minus 6i square root of 3 over 8. And I can divide all of those by 2 and make that a 4, make that a 3, make that a 3. Make sure that you're dividing both of those terms on top. So x is equal to negative 3 plus or minus 3i square root of 3, that's a lot of 3's, over 4. So in other words, this has one real solution and two imaginary solutions. So in this video we took a look at how to factor a sum and a difference of cubes and then how to use that to solve an equation that is a sum or difference of cubes.